Only if I have to repeat myself, because I already said it. So yesterday, what happened was we played a game. When we put back the chip every time, we decided it was an independent event. Why is it an independent event? Michaela.
Because once you put the chip back, it's like a 50-50 chance, but if you don't put the chip back, it's like a 50-40.
Okay, so it's different though, right? For independent, it's exactly the same. My first choice is red, red, yellow, yellow. My second choice is red, red, yellow, yellow, and it's identical. So the second draw does not depend on what happened the first time. And when we tried to find the probability of a red and then the yellow, I drew a tree diagram. Okay, you don't have to, but I did. There were 4 choices for each of the 4 draws. There were 1, 2, 3, 4 ways to get red, yellow out of 16 total ways. 25%. I'm with you, Mrs. Smith. That tree diagram makes sense to me.
Yeah.
If I draw red first, I still have 4 choices. We did another game, but this time we kept one of the chips and we decided that one was dependent. Someone explain to me why this one made it a dependent event. Bree.
Okay, so you would draw one, and let's say you got a red.
Yes.
You put the red out on a table. You wouldn't put it back in the cup, which caused you to get. You could get 1 red or 2 yellows. If it was opposite, you get 2 red and 1 yellow.
Yes, and so what I could get changed. It depended on what I picked first. Steph.
If you like drew a red one, instead of being 2 reds and 2 yellows, 50-50, it would be 25% for.
Well, let's look. Let's look. If I drew a red first, what are my choices? What is still left in the cup?
1 red and 1 yellow.
And so I had a 30%, 33% or 1/3 chance of getting a red and a 2/3 chance of getting a yellow.
Well, if you like chop them, like okay, 2 reds, 2 yellows, and there's 1 red, so I'd be like 50 cut in half. So this is $100.
But we did not cut them in half. We didn't cut them in half. What we did is we took one out, so instead of having 4 choices, there's only 3.
So I just done the 51, the 50.
There was 50-50 to start, but it's only because there were 2 out of 4, and 2/4 is equal to 50%. So to start, we had a 50% chance of getting a red one. But once I draw a red one, I actually have 2/3 of a chance of getting a yellow one, which is what we wanted because there's 1 missing. There's only 1 red in the cup.
Okay.
So it changed my second choice. So my second choice depended on what I got the first time. My second choice depended on what I got the first choice. And so this changed. Now I only have 3 options 4 times. There's still 4 ways to get a red and a yellow. But now how many total options are there? How many total outcomes are there? There's 12 because there were 3 4 times. Each trunk had 3 branches, 3, 3, 3, 4 times. And remember, we're multiplying in this chapter. We're not adding. We're doing the same number over and over, and repeated addition is multiplication. So it's 4 out of 12. That's 1/3, which is 33.33%. So my probability, the likelihood that I'm going to get a red and a yellow is way higher for this one than the other one. Question? Nope, I just wanted to show you. Now, what we are going to do today is talk more about this difference between independent and dependent. What I don't want is I don't want us to have to keep drawing tree diagrams because they're painful, right? But you have to understand that when I draw a tree diagram, for this one I have 4 things 4 times, and for this one I only have 3 things 4 times. But that's where the 16 and the 12 come from. 4 times is 16. 3 4 times is 12. And so we're multiplying the number of options times how many little trunks there are on our tree. That multiplying part is some 7th graders are missing. I'm with you, Mrs. Smith. I can see that in the tree diagrams where I want you to be thumbs up.